Okay, for number 9, it gives us a reaction. Information about the substances are summarized in the following tables. So we know that the delta H of formation, that's what that means, for C2H6 is 226.7. The delta H of formation for C2H2 is 226.7. The delta H formation for C2H6 is negative 84.7. And what's not given, but what we know, the delta H formation of H2 is 0, because the formation, it doesn't take any energy to form an atom. That's how we define delta H of formation. Use the above information to determine the enthalpy of the reaction. So the enthalpy of reaction is going to equal the sum of the enthalpy of formations for all of the products minus the sum of the enthalpy of formation for all of the reactants. Okay, so the coefficients are 1 and 1, the balanced chemical reaction. So the delta H is going to be 1 times negative 84.7, that's the product, I'll put a P next to it and an R, minus 1 times 226.7. Now if I had more than one product or reactant, I'd have to add them up, but now when we do that, you should get negative 311.4 kilojoules. That's the delta H of the reaction. And then it says, write the balanced reaction for the heat of formation. Heat of formation means make 1 mole from the atoms in their standard state, from the elements. So make 1 mole of C2H6. That's what heat of formation means. From their atoms means I need to take carbon. In its standard state, carbon is solid. I need 2 of them. Plus hydrogen, in its standard state, it comes as H2 gas. I'll need 3 of those. Technically, that's all that the equation was asking for. And we know from the table above that that should have been plus 84.7 kilojoules because the heat of formation was given in the above. This wasn't asked for in the question, but it shows understanding.